Kia ora Year 12. In this video I'm going to do a few examples of integration by substitution. Now this is a lot like what we looked at in class last week, except these examples will have trig and logarithms in them, but as before, some of you won't need to use the substitution technique to do them. So if you're confident with your chain rule and differentiation, you'll find that you can do a lot of these in your head. But it's good to be confident with substitution because sometimes we do have to resort to it. So here comes the first one. Once I've written it out, pause the video, grab your pen and have a go. So it's tan squared x plus 1 over tan x plus 1 dx. Okay, so a few things that you might have thought about trying with this one. If you take a very quick look, too quick a look at the top line, you might think you've got a difference of two squares. Sadly you haven't, because you've got a plus 1, so that's not going to work. But the next thing to spot is that the numerator comes from a trig identity. So remember, we've got sine squared plus cos squared is equal to 1, which generates the other two Pythagoras relationships. So tan squared x plus 1 is equal to sec squared x. Now once you spot that, this problem just got a whole lot easier, gets a whole lot easier. So we rewrite that as sec squared of x over tan x plus 1 dx. So now we're in the situation where we've got the derivative of tan x plus 1 in my numerator. So this is one where I just would not do substitution on this. Why am I writing that? I don't want that. I want that to go away. Let's get rid of that. So my integral is going to be the natural log of tan x plus 1 plus c. Because we're back in the pattern type that we saw a couple of weeks ago, which is this, the derivative in the numerator and the function in the denominator. Okay, so when you're doing any kind of fraction for differentiation, always check to see if that's what's going on. And if you hadn't spotted that trig identity in there, it would have been worth going to your formula cheat sheet and just checking how these two things were linked. Okay, so that's the first one, and I'm not going to do that one by substitution. The next one is a little bit similar. Okay, so what's the integral of tan x with respect to x? Well, tan of x is equal to sine of x over cosine of x dx. Now the reason I've resorted to doing that is because back here I've just got tan x. So tan x is not the derivative of any of my basic trig functions. So it's not going to be as easy as if I had a cos x or a sine x. So once we see this, again we've got the pattern where in the denominator I've got cos of x, and in the numerator I've got sine x, which is closely related to its derivative. So this one is going to be something like this, the natural log of cos x. But let's check if that's right, and we'll see that we're not finished yet. When I differentiate this function, I'm going to get 1 over cos x times the derivative of the inside function by the sine rule. But that's not sine x, it's negative sine x. So to finish off this derivative, I need to put in a negative sign. Okay, so we'll get rid of all of that. We need negative log of cos x, and the very last thing before someone tells me I forgot is the plus c, because it's an indefinite integral. Now we can write that even more nicely like this. Using my log rules, this is the same as the log of cos x to the power of negative 1 plus c, which is the natural log of sec x plus c. So that's fine, but that's even better. Now this one I am going to do using U substitution on the next slide, just to show you how to do that. Just skip through the next slide if you're happy with that. Okay, so we'll start out the same way. Tan x dx is equal to sine x over cos x dx, and we'll let u equals cos of x. Differentiating, I get du by dx is equal to negative sine x, which gives me, splitting up the du by dx, du is equal to negative sine x dx. Negative du is equal to sine x dx. So now we're just going to take a look at all the different bits. We've got that in terms of u, and we've got all of that in terms of du. So we can now rewrite. Let's just put that off to one side. This is equal to, let's see, well, it's going to be the integral of 1 over u times negative du, which gives me negative log of u plus c, plus c, there we go. Now we have to pop back in cos of x. We don't want to end up with an answer in terms of u, so negative log of cos x plus c, just as we had it before, or we could go log of sec x plus c. So there you go. I'm going to do a summary on the next slide for Callan, who suggested that I start doing that. So if you don't need the summary and you've made your own one, you can just stop watching. Okay, summary. Here we go. Well, let's think about what we've got out of those two examples. The main thing is to reiterate that when I've got this pattern, that will give me a nice, easy integral that looks like this. So we're on the lookout for those. Sometimes we do them with u substitution, and sometimes we do them without. And the other thing I guess I'd put in my summary is not to forget two things: your trig identities and your basic trig derivatives. Alright, thanks for watching. I'll be back with more videos soon.